Alright, today we're going to talk about radical expressions. Here's kind of the agenda for the day. If you notice, we have three things we're going to accomplish. I'm going to show you how to add and subtract radical expressions, and then I'm going to show you how to do it when you don't need to simplify and when you do. Then I'm going to show you how to double distribute them. Some of you will remember this as FOIL, but you know I don't like to use the term FOIL because it doesn't generalize outside of a 2x2, so I use double distribute. Then I'm going to show you how to rationalize a denominator. Alright, so our next slide, the first thing we're going to talk about is how to add and subtract them without the need to simplify. So let's look at our first example. We have 3 times the square root of 5x minus 2 times the square root of 5x. When I'm doing a problem like this, I have to pay attention to a few things. The first thing I want to pay attention to is I want to pay attention to my index. So I'm going to look here for my index, and I notice that my indexes match. Remember from last week that these are both the square root. Even though there's not a 2 in the index, it's the lowest form of root that we have, so we don't write 2, we just say square root. And then I'm going to check my radicand. It's 5x and 5x, and they match. So long as these match up perfectly, I'm good to go. I've got the same index, I've got the same radicand. So I'm ready to actually add and subtract these, and it's very, very simple. I'm simply going to treat the square root of 5x as like a variable, let's say x, y, or z. So I'm just going to do 3 minus 2 is 1, and that's going to be square root of 5x. You can literally think of it as quantity, because that's what a coefficient is the quantity. So if you read it this way, it makes more sense. 3 square roots of 5x minus 2 square roots of 5x leaves me with 1 square root of 5x. So that's how you add and subtract. You simply just add your coefficients so long as your radicals match up perfectly by index and by radicand. You may want to write that down, so I'm going to say it again. You simply just add or subtract the coefficients depending on the signs if your radical matches up perfectly, meaning your index and your radicand. So let's look at our next example. I have 6 x squared times square root of 7 plus 4x times square root of 5. First thing I'm going to do is I'm going to check out my indexes. My indexes match up perfectly. They're both square roots. Next, I'm going to check out my radicands, and they do not match. So I actually cannot add these together, and so I would say don't add because radicands are different. I'm going to have to type that in the future because that looks horrible. Let's actually just do that. Okay, so we're not going to add because the radicands are different. So let's get rid of this junk. That looks horrible. Okay. So don't add because radicands are different. Let's look at our next example. First thing I'm going to do is I'm going to check out my indexes. And I notice that my indexes, sorry, that should be yellow. Well, alright. Check out my indexes. And I see that my indexes don't match. So I'm not even going to check my radicands. I'm going to say don't add because radicands are different. Okay. Not radicands, indexes. Okay, so that's the basics of adding or subtracting. To review, you can add or subtract them so long as the indexes match and the radicands match, and when you do that, you simply just add up your coefficients. So, adding and subtracting should be that simple. Next, we're going to look at how to add and subtract them with the need to simplify. So, I'm going to look at an example where I have to simplify. The question looks a little bit different, but nothing's really changed. I'm going to... Okay, so even though this question looks a little bit different, it's basically asking me to add and subtract these three things here. So I'm going to take the square root of 12, and I'm going to add to that square root of 75 minus the square root of 3. Now, if I look at these three, I look at my indexes, they're all square roots, so they all match up. But I look at my radicands and they don't match up, and the first thing I would think to myself is, I can't add or subtract these things together because the radicands aren't the same. But then I remember back from about 3 to 4 weeks ago, we learned how to simplify radicals, and this even ties back to last week, so you'll notice that I'm going to simplify these by what we did last week. So I'm going to break these down and see what happens. So 12 breaks down into 2 times 6. 6 breaks down into 2 times 3. So square root of 12, I'm looking for pairs. There's a pair right there, so I pull a 2 out. So this becomes 2 on the square root of 3. That is a 3, even though it doesn't look like it. Now I'm going to erase this work. And I'll break down 75. That's going to be 3 times 25. And 25 is going to be 5 times 5. There's a pair right there. So square root of 75 becomes plus 5 on the square root of 3. Last thing I want to do is break down the 3. And 3 doesn't break down, so I'm just going to put minus square root of 3. So as you should be able to see now, if I take the time to break down my square roots, you'll see I actually end up with square root of 3 each time, and those match. So I'm just going to add my coefficients. 2 plus 5 is 7, minus 1 is 6. So this is 6 on the square root of 3. And I would be done now. Okay? So, I'm going to give you this example. Now, since this is a video, you can pause this at any time. You can rewind and listen to something again. You don't have to just listen to me say it once. You can listen to me say it over and over again. So if you want to, it wouldn't be a bad idea to pause right now, maybe try to work this example, get a prediction for what you think is going to happen, then maybe come back to the video and check your logic. But if you're not pausing the video, here I go. So 18 breaks down into 2 times 9. 9 breaks down into 3 times 3. And I'm under a square root, so I'm looking for a pair. There's a pair of 3's. Now what's funny is, I'm not sure we saw this last week, but there's already a 6 on the outside here, and I'm bringing a 3 out. So I simply just do 6 times 3, and I get 18 times the square root of 2. Alright, plus 50 breaks down into 2 times 25. 25 breaks down into 5 times 5. There's a pair right here. So I'm going to pull a 5 out, but there's already a 3, so that becomes 15. I'm multiplying those two numbers times the square root of 2. So just like in the last example, after I broke down my radicals, I have square root of 2 twice, so I simply just add the coefficients. 18 plus 15 is 33. Square roots of 2. I'm done with that example. So, that is how we add and subtract radicals. To review, you double check that, make sure your indexes match, make sure your radicands match. If your radicands don't match, break them down to see if they simplify into something that does match. If your indexes don't match, there's nothing you can do. So just basically give up on that example. But if your radicands don't match, you can break them down like we did in this example, see what happens. Then once you have them broken down, once they match, you simply just add or subtract your coefficients, and that's it. So next we're going to talk about how to double distribute. Like I said, this lines up with FOIL, but I like to call it double distribution. What is the product of each rational expression? Okay, so with this one, I'm going to double distribute. So I'm going to do 4 times 5. Then I'm going to do 4 times 4 square root of 2. Then I'm going to do 2 square root of 2 times 5. Then I'm going to do 2 square root of 2 times 4 square root of 2. First thing is 4 times 5. That gets me 20. Next, I'm doing 4 times 4 square root of 2. So I do the 4 times the 4, and I get 16 square root of 2. Next, I'm going to do 2 square root of 2 times 5. 2 times 5 is 10. So I get 10 square roots of 2. Last thing, and this may be something that may trip some people up, so I'm going to go slowly. I'm doing 2 square root of 2 times 4 square root of 2. Multiply the coefficients, and I get 8. Now this is going to simplify, so I'm going to put that over here. 8. Now I multiply my square roots. Square root of 2 times square root of 2 is the square root of 4. The square root of 4 I can simplify as 2. So this becomes 8 times 2, which is 16. Okay, for those of you that didn't get that, 2 times 4 is 8. Square root of 2 times square root of 2 is square root of 4. But this equals 2. So it gets me to this over here. Okay? So, 8 times the square root of 4, but the square root of 4 is 2. So I bring the 2 up here and I do 8 times 2 to get me 16. Now I'm just going to combine like terms. 20 plus 16 gets me 36. And just like before, since my square root of 2's match perfectly, I add my coefficients, and I get 26 on the square root of 2. And that is my final answer. Here's another example. Like I said before, I recommend that you pause the video, maybe work this one and get a couple steps ahead, check yourself. I don't always recommend that you work the entire problem. Maybe work a couple of steps and then watch and then pause again. So I'm going to do 3 times 5. Then I'm going to do 3 times square root of 7. Then I'm going to do negative square root of 7 times 5, and negative square root of 7 times positive square root of 7. So 3 times 5 is 15. 3 times square root of 7 is plus 3 square root of 7. Negative square root of 7 times 5 is negative 5 square root of 7. Over here to the side, negative square root of 7 times positive square root of 7 is negative square root of 49. And 49 is a perfect square. Its square root is 7. So this just comes out to be negative 7. Now I combine like terms. 15 minus 7 is 8. And then 3 minus 5 is negative 2. So I get negative 2 square root of 7. And that would be my final answer. So that is how we double distribute with radical expressions. So that brings us to our next point. The last thing we're going to work is how to rationalize a denominator. This process can be lengthy. So what you may want to do is you may want to just take a quick break, maybe work a couple problems from the previous stuff. Just kind of make sure you have that before you start this part of the video, because how to rationalize a denominator can be a lengthy process. So I'm going to go ahead and go because you have the power to stop, pause, do whatever you want to. So here's our first example. How can you write this expression with a rationalized denominator? Now we've seen this strategy before when we use the conjugate. So I'm going to take the conjugate of the bottom. So I don't know if you guys remember, but I hope you do. The conjugate is basically the exact same expression, but change the sign in between. So I'm going to use square root of 5 plus square root of 2, but I have to multiply top and bottom by that. So now I'm going to double distribute. I don't know if you've noticed, but every time we've gone up a level in this lesson, I couldn't do the next level without knowing the previous one. I can't double distribute because I don't know how to simplify after I've distributed. I don't know how to combine my like terms. And I can't rationalize the denominator until I know how to double distribute, because as you can see right here on bottom, I'm going to have to double distribute. So this lesson really lends itself to scaffolding, which is really nice. So on top, I'm going to do 3 square root of 2 times square root of 5, and I'm going to do 3 square roots of 2 times square root of 2. On bottom, I'm going to do square root of 5 times square root of 5. I'm going to do square root of 5 times minus square root of 2. I'm going to do minus square root of 2 times minus square root of 5. And I'm going to do minus square root of 2 times positive square root of 2. So I've got lots of multiplication going on here. So let me grab my red marker. I'll do the top in red since my arrows are in red. 3 square root of 2 times square root of 5 is going to get me 3 square root of 10. Then plus 3 square root of 2 times square root of 2 is going to get me 3 square root of 4. But remember from earlier that square root of 4 is a perfect square. So the answer to that is 2. So really that's 3 times 2, which is 6. If you have a question on that, re-listen to that part. I think you'll pick up on why this is 6. If you need to, write out the steps and you'll see it. So before I move on, I'm going to see if this square root of 10 can simplify. 10 would break down into 2 times 5. So I don't have a pair of numbers in there, so square root of 10 doesn't break down. On bottom, I'm going to use green. Square root of 5 times square root of 5 is square root of 25, which is 5. Plus 5 times square root of 2, which is square root of 10. Minus 5, or square root of 2 times square root of 5, which is minus square root of 10. And then negative square root of 2 times positive square root of 2 is negative square root of 4, which is negative 2. Now, if you've done this part correctly, these two middle terms should always, always, always cancel out. The whole point of rationalizing the denominator is to get rid of radicals on bottom. We actually saw this before several weeks ago, so this is actually being revisited as we deal with radical expressions. So these two pieces right here should cancel each other out. If they don't, you've messed something up. So let's simplify this. I get 3 square root of 10 plus 6 over 5 minus 2, which is 3. Now, the last thing you should pay attention to is look at all your coefficients. So I have 3, I have 6, and I have 3. See if anything goes into all of them. 3 goes into every single one of these. So I'm going to divide everything by 3. So this becomes 1 square root of 10 plus 2 over 1. And we really know that these 1s aren't necessary. So this is square root of 10 plus 2. And that is rationalizing the denominator. I recommend, if that didn't make sense to you, before you ask me or anybody else any questions, watch that again and to see if you can pick up on something that you didn't pick up on before. Of course, be more than happy to help, but I'm just trying to do more to make you guys independent and figure some stuff out with the least amount of help as possible. So let's look at another example. Like I've said before, I recommend that you guys pause the video, maybe start working this one, maybe go step by step, think to yourself, what would I do first? Then hit play, see if I do the same thing you would do. If not, that's great, you can correct your step, but at least you don't get 5 or 10 minutes into this example and realize that you've been working it wrong. So the first thing I'm going to do is I'm going to multiply by my conjugate. So I multiply top and bottom by the conjugate, so that's going to be 3 square root of 3 plus 2. And I do that top and bottom. So now all I have to do is multiply. 4 times 3 square root of 3 is 12. 12 square root of 3. Plus 8. That's the top. 3 square root of 3 times 3 square root of 3 is going to be 9 times 3, which is 27. 3 square root of 3 times 2 is plus 6 square root of 3. The next one is going to be minus 6 square root of 3. Remember, I want these to be opposite of each other. I want them to cancel out. And then negative 2 times positive 2 is negative 4. So these, the pen's going a little bit crazy tonight. So these cancel out. Equals 12 square root of 3 plus 8 divided by 27 minus 4, which is 23. Back here, I really should have stopped to think if this square root of 3 is going to simplify. 3 is a prime number, so it will not simplify. At this step, I'm going to look at basically my coefficient and my two constants. See if anything goes into all of them. 23 is a prime number, so nothing goes into all three of these. So I am staring at my answer. Alright, so I hope that now you're a little bit better with radical expressions. I hope that you can now add and subtract them. I hope that you realize that you may need to simplify sometimes. I hope you know how to double distribute and combine like terms. And I hope you now know how to rationalize the denominator by using the conjugate. So I hope this lesson helped. If you go back into Canvas, you'll find some practice work to make sure that you know what you're doing.